A unity feedback control system is characterized by the following open loop transfer function g of s equal to 4s plus 1 upon s multiplied by s plus 6. Determine its transient response for unit step input and sketch the response. Evaluate the maximum overshoot and corresponding peak time. So g of s is given unity feedback system. Therefore, t of s equal to closed loop transfer function is numerator of open loop transfer function divided by unity feedback system, denominator plus numerator, that is closed loop transfer function. Therefore, the closed loop transfer function is 4s plus 1 upon s multiplied by s plus 6 plus 4s plus 1, that is equal to 4s plus 1 upon s square plus 6s plus 4s plus 1, that is equal to 4s plus 1 upon s square plus 10s plus 1. Here, the roots are s equal to minus b plus or minus square root of b square minus 4ac divided by 2a. That is equal to minus 10 plus or minus square root of 96 divided by 2. That is equal to minus 10 plus or minus 9.8 divided by 2. That is equal to minus 9.9 comma minus 0.1. These are the roots. Roots are real and distinct. Real and distinct. Therefore, it is a overdamped system. It is a overdamped system. Overdamped system. So, determine the transient response for the unit. Determine the transient response we have to find. T of s by r of s, input r of s equal to, that is T of s equal to 4s plus 1 upon, now we got the roots s plus 9.9 and s plus 0.1. So factorized. That is here response, find the transient response for unit step input. Unit step input means r of s equal to 1 by s. R of s equal to 1 by s. Therefore, this implies C of s equal to 4s plus 1 upon R of s. If you bring that R of s here, you will get s in the denominator. S multiplied by s plus 9.9 multiplied by s plus 0.1. That is equal to a by s plus b by s plus 9.9 plus c upon s plus 0.1. S multiplied by 4s plus 1, 4s plus 1 upon s multiplied by s plus 9.9 multiplied by s plus 0.1, where s equal to 0. That gives a equal to 1. B equal to what? B equal to s plus 9.9 multiplied by 4s plus 1 upon s multiplied by s plus 9.9 s plus 0.1. S equal to minus 9.9. That is equal to plus 0.43. C equal to what? 4s plus 1 upon s multiplied by s plus 9.9. S equal to minus 0.1. That gives minus 0.61. There we got the values of A, B, C. Therefore, the response C of T equal to A equal to what? For this Laplace inverse of this is 1. A equal to 1. Therefore, 1 plus D equal to what? D equal to 0.43. 0.43 e power minus 9.9 t minus c equal to minus 0.61, 0.61 e power minus 0.1, 0.1 t. This is the response. This is the response we got. One answer we got. This is the determine the transient response. We got the transient response. And sketch the response. This is overdamped. Therefore, the response is overdamped. Right? Here it should not have a 90 degree. This is first order response. Therefore, let us draw like this. This is not correct. This is correct. Here it should not be 90 degree. Only first order response will have 90 degree here. So this is the response for second order overdamped. Typical response. So sketch the response. Evaluate the maximum overshoot and corresponding peak time. No overshoot at all because it is the overdamped system. Therefore, the overshoot equal to 0. MP equal to 0 because no overshoot at all. Corresponding peak time equal to no peak. Therefore, infinity. Up to infinity, no peak occurs. It never happens. Therefore, we can put infinity. Or you can write no peak overshoot at all. That's why there is no peak time. That way also you can write.